So, guys, for me, this gentleman was a kind of hero. What was his name? Gary Kasparov, right? And the other one is Anatoly Karpov. So it was almost 1990 some that they always had battle. Before that I came into this sport, can you imagine? Yeah, don't look at me that way, okay? So the thing is, I followed the news, and I really like this one to win the game always. But in 1996, they started a project to have human on one side and the computer on the other side. So Gary Kasparov versus computer. And the name of the project was Deep Blue. That was the first time that I heard about artificial intelligence. Part of me wanted this guy to win, part of me wanted computer to win because I accepted by computer engineering department and wanted to just see, okay, if it can work. The first year, with huge margin, with 2-mark difference, 2-score difference, Gary Kasparov won the game. The next year, they utilized the computer, the Deep Blue computer, with a strategy they call it brute force attack. And what is brute force attack?
Just trying
everything, right? For example, if you have 3-digit kind of log, you just say 0000001, and always you ended up finding that, okay, the password was 999 or 998, right? So that's how it works, brute force kind of attack strategy. Anyway, it was the beginning of the time that I know about artificial intelligence. By showing hands, please tell me how many of you had this presentation before? So for sure you, and 1, 2, 3, 3.5, maybe? Okay, so just part of our group. The thing is, I'm gonna summarize it as best as I can. So at the end of this presentation, you're going to have a kind of clear definition of machine learning, because we always have that question. Which part is machine learning? Which part is artificial intelligence? We have heard something in the middle as well, like they call it expert systems, maybe. We heard about data science. We heard about deep learning. So what could be the relationship between them? We are going to have a clear definition. And also the difference between apple and orange as a kind of classical hello world problem for machine learning. And then we're going to talk about classifier. Okay, what is classifier? Supervised learning, unsupervised learning. And we talk about a sort of recipe, a simple recipe to collect, train, and predict using machine learning. Okay. I already talked about Deep Blue project. Now we can see the computer. After winning the game, they just and they just won the game with 0.5 advancement of the computer compared to the human. They just treasured it in the museum because they were frightened that what if the next time Gary Kasparov is going to be. We can say the problem of AI was this. It was just excel. It was just excel in one task. And we call this kind of AI symbolic AI. Okay, so symbolic AI is a kind of AI that can just do one job at a time. So you cannot customize it and use it in something else, like predicting weather or something different, right?
Is it also called narrow AI? Is that the same thing? Narrow AI?
I haven't heard that. Yeah. But the thing is, the general idea, right now they say, okay, early AI, or what we call it symbolic AI, is just one subset of total overall AI. So you can look at it as a kind of very big circle, which part of it is machine learning. Okay, so machine learning in general is a kind of subsidiary of AI. But what is the aim of machine learning? We want to write a program that can solve a number of problems without being rewritten. The problem of early AI was you needed to define many rules for any movement. So it was not a kind of brilliant idea to write something from the scratch again for any new problem. So that's the intention of having machine learning, to write one program and reuse it for different problems. While we are talking, there are some champion league happens. One of them is AlphaGo. Well, we already had that almost 3 years ago. They found a champion that could beat the heroes in the field of in the field of Go game. And the thing is, those who have deep learning living, they know that we call this part, the hidden layers, that they could be first convolution, and then we feed this layer, which could be input layer, and then other input layers, hidden layers, and then we have the output. The same mechanism can work to play an Atari game. You don't need to change anything, right? You don't need to change anything. You can just bring this algorithm to next problem. Can we say machine learning contains algorithms that learn from examples and samples and try to find pattern between input and outputs? Yeah. So in traditional languages, we had this concept that we gave the rule and we fed data and we expected the program to give us some answers. So we define the rules, we provide the data, and we expect information as the answer. But here in machine learning, we provide answers that we expect to receive based on the data that we feed, and we want machine learning to predict those kind of, to provide those kind of rules for us. Okay, so let's get to this classical problem to write a program that can distinguishes apple versus orange. Okay, you have the answer, so I cannot, who said that this is the first time? Aisha, is this the first time? At least pretend that that's the first time. So what are the things that you are going to use in order to say, okay, this is apple, this is orange? In a classical form of application, imagine that you want to define some functions. What is the keyword to define function in Python?
Def.
Def. Okay. So you say def. What could be the function for this? What could be the functions? One could be the color, right?
Features.
Which features are you going to?
Color, shape.
Color, one. Okay. Shape. But intentionally, I've chosen something that has some orange-ish kind of things here, and some red-ish sort of thing here. So if the color cannot work by itself, could ratio work as well? Right. Because the ratio of orange is very high, while the ratio of orange there is very low, and so it could be ratio, right? Color, shape. In one of the sections,
Texture.
people said, yeah, texture. One of the sections, people said, taste. I said, okay, leave it. If you don't eat that much food, you can leave it. So the thing is, yeah, shape could be, and the texture is one is, which one is smooth? That one, right? If you just feel it, close your eyes and you feel it, okay, this is smooth, but this one is bumpy. So these are the features. So let's just write a few of them, like color, edge, shape, texture, and so on and so forth. But the thing is, when you go to the real world, the real world is actually very messy, and the regulations that you have defined are going to collapse just by changing a few default assumptions that you have. Like, you said, let's have two different colory fruit, what if I just change it to black and white kind of thing? What if I just change the fruit, instead of having apple and orange, replace it with grape and banana? So the whole things that we have defined are going to collapse down. Okay, we need something better, we need something general. In that case, we can say machine learning is pretty close to a function that we know. So in that function, we have some features here. We feed a function with those features, and we expect some labels. So in a very kind of simplified version, how many columns do you think that we should have for machine learning in the simplest scenario? Yes, Alec.
2. No, I didn't say anything.
2.
2.
As many as you need.
As much as you need, but what could be the minimum number of columns?
Maybe 1.
Maybe 1. Okay, so now, wow, for sure, it shouldn't be 0, right?
Yeah.
But let's say, why not 1? If it is just one feature, then you can just simply replace it with if then else.
Yeah.
Isn't it? So it's got to be kind of simply, if it is bumpy, then if it is, So normally, when we have number of parameters, and that's exactly the case that we have in many problems in computer science environment, when we have more than one parameter to work with, to measure, we use machine learning as one of the possibilities. Before that, we had some statistical sort of things. One of the big differences that we can say machine learning has compared to the previous generations that we had just simple statistics is this: the number of elements that we can evaluate. Because normally in statistics we work with 100, maximum thousands of columns or rows. But right now we're talking about millions or billions of rows. So the data set is gigantic compared to previous simple statistics. Okay, so we can say that's the classifier, but before going further, can we come up with some examples that we work in daily basis using machine learning? Any example?
Weather prediction.
Weather prediction, right, exactly. So that's what we have, some data from previous, we predict based on using that. What could be the other thing? Okay, fraud detection in banking system could be another one, right? What if you have a kind of huge transaction while you most of the time use that specific card for your grocery shopping, right? So it's a kind of big difference, then they're gonna just give you an alert that, was it you? Or when the distance comes to the game, for example, you cannot be at the same time here and in Texas, right? So what if the transaction happens at the same time or close to each other? What else that we use?
Social media.
Social media, yeah. Satish, don't do that.
No.
So I'm telling you. So imagine if you start adding people anonymously in Facebook, it's gonna first give you an alert, right? Say, hey, Satish, don't do that. If you keep doing it, it's gonna block you. Okay? That's a good example. Okay, so it happens. Why? Because there's a kind of machine learning algorithm behind it. It says that, okay, this person add people without having those kind of connections that you expect. Okay? And then that happens.
YouTube.
YouTube?
Yeah. And so
Did it block you again?
it recommends video based on your like what types of videos.
Awesome.
Recommendation engines, isn't it?
Excellent example. We have something that they call it customer recommendation system. Right? What is customer recommendation system, guys? What if you start buying something from Amazon? Okay? The next time it's gonna say, okay, who ordered this, also ordered this, and also ordered this, and also ordered, okay, I'm gonna just buy all of them, don't worry. So it's gonna just try to feed you. If you just go to Netflix and say, hey, I want to watch this, it's gonna kind of force feeding you. It's, hey, those who watch this, they watch this and this and this. That's a kind of, and I'm telling you, some of my friends, they freaked out and said, the big brother is watching you. Well, yes and no. The yes part is actually there is a mechanism that watch you, wherever you go, whatever you do. But the good thing is there is no person behind it. It's a kind of algorithm. I don't know, should we feel better or worse when a mechanism does the same thing, that we are afraid of being traced and chased in the communist, for example, environments before? Right, that we have the same mechanism. Everybody is tracked and chased by those kind of surveillance cameras. And I don't know, right now I don't have that much fear. Maybe in future we will have, but right now it's kind of under control. Anyway, the other thing that I wanted to give you as an example, apart from customer recommendation, is simply the email that you use. So it says that, okay, this email belongs to this category or the other. So these are all the examples that we have. And yes, it says that if your email that you receive is spam or not. So how can it detect that? And the other thing that as a person who talks English as his second language, I always use that kind of Google Translate, and they started getting better and better. And almost this is 2 years that the speed rocketing to the sky is rocketing to the sky, and the accuracy is very high compared to, for example, 3 years ago. I'm saying 3 years ago, it was horrible. You just, should translate the translate of that translation. But right, that is pretty accurate. And the reason for that, they're using deep learning mechanics. Let's talk about the supervised learning. We have 3 general form of machine learning. We could classify more, but these are the mains. One of them is supervised. In supervised, you have some columns as your inputs, and you have one column as the output, which you say, okay, apple or orange. But what if you don't have any specific column as the output? Then you call it not classification, you call it clustering.
Yeah.
And clustering could be, there are many usages for it. Like just seeing the picture and then say, okay, the saturation of one color here is higher than the other. And you want to say, okay, people, for example, in patients, in medical images, those who have the saturation of one color here, they are prone to have, for example, heart stroke or so on and so forth. Right? So the ideal form is to bring the unsupervised learning or clustering towards clustering. If you can have, that's the ideal. If you can just bring those guys to labels, that's the ideal. If I can say, okay, those who have this, they are equal to patient. Those who do not have this, they are not. But this is a kind of, transient level. Apart from it, you have reinforcement. What is reinforcement? It's like, simply good dog, bad dog, to just reward or penalize robots or something that you want to, and it's exactly the pattern that we learned and grew up with when we were kids, right? And the thing is, many robots, they start learning like that. And guys, let me ask you one question, and it's a kind of philosophical question. So, when do we feel bad? We feel bad when somebody says that, hey, for example, Reza, this is not an appropriate behavior. You say, oh, you see, it's like, bring me to that level that I'm a bad child, right? So it hurts part of my pattern of feeling. What I want to tell you is, you are teaching a robot based on that good dog, good boy, bad boy kind of pattern. So are we creating emotions for robots, technically? And the hardest question is, are we going to be responsible for that? So that is why it's not that much off topic that they predicted that in a few years we are going to have policies and conventions how to treat robots. So simply, be careful if you want to buy any robots from now on, because you cannot treat them very bad. So, and pretty soon we are gonna, here is Toronto, right? Pretty soon we are gonna have the strike of robots in the younger streets. So the thing is, that's another, and we have some other form of, learning, but let's go to our track. So we talked about features, labels, defining classifiers, and we said when you say function, it is as simple as saying, can you please just check on this for a second? Yes, and when we say a classifier, well, it's equal to say, for example, y is equal to ax plus b. What do we call alec a? It's alec, not alex, right?
Alec, yeah.
Alec, okay. What do we call this? It's the slope,
Yeah.
and this is y-intercept, right? So let's say, what if we say, I don't know, 2x plus 3, something as simple as that. Imagine that y is like this, right? So what if we say x is 0, what's the output for y? 3, right? Okay, what if I say x is equal to 1, what is the output for this? 5. So you just imagine that this is 0 and 3, imagine it's 1, 2, 3. And this is 1 for x, and this is 4, 5. This, and you simply just draw this line. So this is the function, right? So if you have just 2 points of that, so you can simply draw that function. I'm telling you, this is the simplest form of function as well as classifier. What do you mean by classifier? Let me just bring you to this. Okay. So the x could be, I mean, in the simplest form, one feature, and it's going to provide us one label, which is y. Let's not talk about this. But what if there isn't any sound for it, right? Like, we need something like that to mix it. So we have some green spots there, some red spots here. The simple form of classifying them to 2 categories could be one simple line, right? And what if I ask you what color is this one? Tell me. Don't tell me gray. I received that answer previously. So yeah, it is in that category, so it should be green, isn't it? Awesome. So how you can just justify that this should be green? So you see how magnificent our brain is by just saying, okay, this one, we just rotate it, and then we say, okay, this part belongs to left side, right side, so say left side is green, right side is. Exactly that's what's happening. No matter if you have a bunch of more, or just simplify it like this. So we should have something like this, and that's actually a classifier. But the question is, I want you to think, so that works even if you say m is equal to 2 and b is equal to y. So if you just change the values, still it works. But the question is how the very first line works. How can you define a and b to define this? Alec?
Sure, random points, you said.
Random points. You were in the class.
Yeah.
Yeah. Ruined the whole thing. You have to say something different. Exactly. So the thing is, if we say, hey, calculate, for example, anything, well, that's not machine learning. It just randomly pick one A, one B. And let's see if it works with this one. So yes, it works. The left side is green, and we have nothing in right, so it's not gonna contradict. But what if I have one dot there? So it doesn't work. Simply, I change it to a new number, then it works. And I'm gonna just adjust it as much as I need to in order to make it better. So these are the libraries that we can work with. So scikit-learn as well as TensorFlow. But for the sake of this example, because we're going to work with simple classification, we're going to use scikit-learn. But look at this one. Here, in a notepad, I said import scikit-learn. It's exactly the topic that we need to cover next session. If you use just library like that, and if there's something belong to that library, like random forest, like, I don't know, decision tree, then you have to use it like scikit-learn dot dash random, sort of random forest array. What if you want to use it without that kind of prefix? You have to say from scikit-learn import that specific part. Then you don't need to have the first part, right? Okay. And here is the time for going through our collecting training data. I'm not gonna, in the break time, we are going to see a few methods of implementing that, but for the sake of today, I'm gonna just quickly tell you. So we have 3 different phases: collect training data, and train our classifier, and make prediction. First, you have to collect those answers, isn't it? Data as well as answers. Then you need to create the kind of algorithm behind the scene. That's the role of computer. And after that, the responsibility of computer is to predict the answer for out of sample examples. It could be any new sample that you want to actually predict, or it could be a part of your testing data that you want to see how accurate your algorithm works, right? It could be either cases. So for the first part, we collect the data. Let's imagine that we are heading towards an orchard and we pick some random fruits, and then we just, for the sake of simplicity, we pick these 2 columns, so weight and texture. And that's the label, that's the output that we expect to have. And look at this one. Okay, so we have features like 140 smooth. Just trust me, for the sake of this, just slide. 140 smooth apple, 130 smooth apple, and the rest, which are heavier, are bumpy and orange. So look at this one. Here we say 140 smooth apple, 130 smooth apple, 150 bumpy orange, 170 bumpy orange, right? So technically these 2 this, these 2 this, these 2 this, and these 2 this. We want to have features as our inputs, and we want to get that output. These are samples, and we want to train our classifier, okay? The problem of scikit-learn is it's not that much friendly with strings, so we need to replace them with, let's look at this one. Instead of apple, we say 0, and instead of orange, we are going to say 1. So apple, apple, orange, orange, and 140 smooth, so 1 is for smooth, and 0 for bumpy. Does it make sense? Awesome. So now we have done this, let's go to the next step and train our classifier. For train our classifier, we simply use a decision tree, and the reason for that is decision tree is the easiest one to interpret and to understand. So these are the reasons that we use this one here. But so here you see I changed this one into, from scikit-learn import, and I set CLF, you can say classifier, it could be any name, is equal to tree, which is here, dot decision tree. If I didn't use that from sort of thing, I needed to say scikit-learn dot tree, dot something, right? Okay, so question, do you think that this CLF already has the rule and regulations?
I don't think so.
It's just an empty box of rule, right? But the idea is to say, hey, CLF, please go and find the relationship between features and labels, right? That's the whole intention. Cool. So let's go to the next step. Here we say that the training classifier, if we consider a classifier as a box of rules, we can say what? We can assume a learning algorithm as the process that creates those kind of rules for us. So we want machine learning to go by itself, find those kind of relationships between input data and the output, and say, aha, this is the pattern. I assume that if it is heavier, high probability it should be orange, and if it is bumpy, yeah, It's gonna, intensify the guess that it is orange. But if it is smooth or lighter, high probability it's apple, right? That's how you can conclude yourself. So we expect the computer to just conclude like that. So up to this point, we just had those 5 lines. And then the 6th line says that CLF is equal to CLF.fit, means find patterns simply between features and labels. Does that make sense? And then the last part is to predict. And predicting means, okay, let's fit something that we haven't seen before. It's not in our range. So it is 160 and 0. What if it was something like 150 and 0? It was just, like a lookup table in the Excel. We want something new, and we want to see if it predicts. So as I told you, that 0 is what? Is for apple, and 1 is for orange. Just please guess what could be this one. It is almost heavy, and it is bumpy. So it could be orange, and the orange, if you remember, it was 1. So by running that algorithm, you see that simply you can have that. And the good thing is, if you say, so what are the possibilities for me to just implement that? There are tons of possibilities. It's exactly the time that you have the code for, you have the code here. So let me just say Control C. And if I go to, what's it, Jupyter? Yeah. This is one online, quick sort of things to work with. Python. Simply you can go to Jupyter. After a few seconds, you see that there is one gizmo in the middle. It says that, okay, everybody can access to internet, right?
No.
Thank you. It's recording, you have to say yes. Okay, so, don't worry, you're gonna just take care of it, but in a few seconds. What if we say plus, then we say Python 3, and then we have an environment that's pretty close to what we have in Jupyter notebook that we use in Anaconda. So I'm going to talk about Anaconda in no time before we have a quick break, and then we're going to, let me just run, copy all this code, and if I simply say run, look what's going to happen. It gives us that one that we expect to receive. Right? This is one of the ways that you can, and they are sharing the same thing, because you're working with some resources on the cloud. After a while, if you don't work with that resource, they want to release it, right? So they say that you are disconnected. They want to reconnect. They always ask that. For example, there's a kind of buffer time for it. It's like 10 minutes or 20, I don't know. The other environment that Shika introduced me almost 2 semesters ago, right?
Yes.
And I really enjoyed it. So if you just log in here, and it has some advanced libraries that you cannot easily find in something like Jupyter.org. So you can just simply say new notebook, and it gives you pretty close to that environment. The more the time passes, the more I like this environment. So simply I copy and paste, okay? Copy and paste. I love these kind of things that happens exactly the time that you don't want that happens. So let's just say import from sklearn. Oh, apparently now I know why it doesn't. Come back here. Hopefully copy cell. Yes, come here. Paste. For God's sake, paste. What did you do to this, Satish?
Right,
Copy.
edits. No, not good.
There isn't any edit, okay. So, okay, it works. Guys, honestly it works. Let's just try one as it at a time. Control C, Control V, edit. There isn't any edit.
Edit menu, the edit menu.
No, oh, okay. Select all cells,
Paste, no.
paste. Control V. Swear to God. Use Control V. Guys, I don't know why now it doesn't work. So even if I say editing, it doesn't work. Anyway, it should work. Okay, just trust me for a second. I'm gonna just bring it to life again in a few seconds. But generally, if you say import, I don't know, sky learn, and you run this, it should work. Yes, thanks heaven, at least it works. Or if I say from sky learn, import decision tree, it should work as well. Decision, import tree, just tree, sorry. And yeah, and it goes to the next and so on and so forth. So it works, hopefully. Just one thing, somebody search why it doesn't work now, please.
I tried it, it's working for me.
It's working
It's
for
working
you.
here as well. I'm trying.
Okay, guys, apparently just once this computer that is recorded not to work. Okay, sometimes you have to restart your computer. That's the only solution.
I guess it's not copied properly. Maybe try pasting it somewhere else that we can see.
Okay, how about this? I just say copy and paste it here.
Okay.
And then I bring it here and I say copy. You see, it worked. Like that. Man, take that part out of video, okay?
Save for the bloopers.
Yes, okay. Guys, I'm gonna give you bonus marks not to tell. Okay, so now it works. The whole intention was, just saying that it works. The other thing that I want to tell you before getting any further is, let's go to our new course, which is session 1. Yeah, prerequisite. That's the installation of the whole thing. Normally, we want to have our local installation as well. So in the local installation, look at this one. We just go to Anaconda, and you already have. Oh no, you don't have it. What I'm going to do. This is how it works. So I'm going to copy this one to the amazing group. This is the installation. Okay. So this is the Anaconda. The difference between what we learned in the previous package and this one is this part. When you want to install, it asks you, do you want to? Please check this one, although it's going to give you warning. That's the only way. Otherwise, you have to go lots of here and there to fix the problem. So if you check this one, it's going to give you permission to install something like Keras separately. So that's how it works. And after that, you simply install Keras. And this is the Conda update and then install Keras in order to have that in your life. To finish the current slides that we started talking about, let me just tell you one thing. Technically, this is a kind of hello world program for machine learning. We have a beautiful classifier for most things to say if it is apple or orange. And guess what? We just have 6 lines of code. That's what we need to finish our first classifier. And I promised at the beginning that we write a code for one kind of problem, but we can reuse it for several others without changing the algorithm. We don't touch the algorithm, we just change the data set, right? So here we have horsepower plus seats, number of seats. And we can just classify if the car is a sport car or minivan, right? And the next question, which in the data science 2, team members like Jay could answer is, okay, can we use the images instead of using, what do we call it? Simple text or the numbers. Can we use images? The answer is yes. There's just one thing I want to conclude the first set of slides with is, guys, if machine learning is the only tools that you know, it's like a hammer and you want to just look at all the problems like nail, that's that you can just look at everything like nail and try to just destroy that. But the reality is, machine learning is just useful when the type of data is not structured. I repeat it, when the type of data is not structured like images, like voice recognition, like any of these samples, like handwritten digits. We have tons of examples that we use in QRS. And if somebody asks me that, okay, Reza, you said QRS, and I wanted to know what is it. The thing is, it's a kind of top-level library that works the other libraries like TensorFlow as the backend. So Tiano is the other option, so we can just switch it. And there is another library introduced by Microsoft. So we can just tune your keras in order to use them as the backend. But right now it is on top of the, as a kind of backend library on top of the others, and we can just do the changes. And the last thing is, okay, for next we have to see how does this work in the real world? How much training data do we need? And how is the tree created? What makes a good feature technique? By saying that, let's just conclude the first set of slides. The next two will be very quick. You have the slides, you will have the video as well if you left behind the linear steps. And I don't think that you need any extra things for just implementing them. So let's just stop it for now. Thank you.